Right, so the plus and angle X, they are the same. B and Y, they happen to be the same. And C with Z happen to be the same. So since all three pairs of corresponding angles are the same, triangle ABC is similar to triangle XYZ. Okay? No. Okay, now, class, I need your attention. Not only each pair of corresponding angles are equal, not only this, but the pair of corresponding sides, they are proportional. Which means, if we come back to this pair of triangles, ABC is similar to XYZ. If this is 2, 3, and 4, if this is 2, 3, and 4, then I tell you that, hey, this is 1. You are able to tell me what is X, Z. What do you think X, Z is going to be? 1.5, you're right. What do you think Y, Z is going to be? 2, because the scale factor is half. Okay? From the original to the new one, it got smaller. It is a reduction, so the scale factor is half. So all the sides, they are proportional. So these are the two properties of similar triangles. So in point number 1, when we say that the corresponding angles are equal, this is how we write it out. And when we want to say that corresponding sides are proportional, we are going to use this. They are proportional. So we're going to use fractions. In other words, if I want you to prove that these two triangles are similar, but you are not allowed to use the angles, this is what you have to do. AC over XZ. I'm writing the ratio of the corresponding sides. This gives me 3 over 1.5, which is 2. Then I'll write BC over YZ equals to 4 over 2, which is 2. Then the last one, AB over XY equals to 2 over 1, which is 2. Since all three pairs of corresponding sides are proportional, triangle ABC is similar to triangle XYZ. Okay? Generally, this is the whole idea for similar triangles. So we'll look at the tests that we can use. The very first test we're going to learn is makes use of this property. Each pair of corresponding angles are equal. Okay? So here we have the name of the test. What is the name of the test? Angle, 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 similarity test. What is the abbreviation? Try again, what is the abbreviation? Because we are lazy to write angle, 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 similarity test. What shall we write? A, similarity test. Shall we write this? So all listen up again. Everybody listen up. Look at what I wrote in black. A, similarity test. This will give you 0 marks. Okay? I don't care what your tutor tells you. I don't care what your elder siblings tell you. The moment you write A, similarity test, you'll be penalized. What do we accept? We accept only this. When you want to use the angle, angle, angle similarity test, your explanation can only be 3 pairs of corresponding angles are equal. Okay? I'm making that very clear right now. I'm making that very clear. You are not allowed to write anything else. So, let's go straight into try it 5. I only want to draw one. Since I already have the small triangle over here, I shall now draw the big triangle. And this is A, B, C. This will be compared with A, P, Q. Okay, you only learn one test. What is the test so far for similarity? Hey, you need to memorize this, huh? Go back to this highlighted one, put a star and write memorize. 3 pairs of corresponding angles are equal. Okay, back to this. How do we prove that these two are similar? Which one, Avro? BAC equals to PAQ. Okay, that is the first one you want to say. Angle BAC equals to angle PAQ. What is the reason? Do you all agree that these two angles are the same? Obviously, they are the same angle, right? They are literally the same angle. Common angle. Okay? I got one angle already. What's next? APQ. Angle APQ equals to angle ABC. What is the reason? What's the reason? Oh, found on top. Ah. Yeah, okay lah. You can write found. In A part 1. Okay, but so now I want you to do A part 1. What is the angle equal to ABC? Right? APQ equal to ABC. But what is the reason? I want you to write the reason. Corresponding angles, parallel lines. You know, I get so irritated when I see students missing out this part in green, highlighted. Corresponding angles, parallel lines. It is only because there are parallel lines, that's why I can have corresponding angles that are the same. So remember what I wrote down on the board yesterday, one whole list of reasons. You are supposed to know every single one of them. Okay, I've got 2 angles already. What now? AQP equals to ACB, is it? Okay. What do the rest think? I've got 2 pieces of evidence over here. My test requires 3 pairs of corresponding angles, right? But we are all smart people. Huh? I proved that 2 angles are the same already. What can you tell me about the third angle? Since it is a triangle, what can you tell me about the third angle? It's the same, is it? So why is it that you're so sure they are the same? Okay, angles are a triangle, right? 180 minus 2 of the same angle, obviously must get the same answer, right? So, need to find the third angle. In this case, you have the opportunity to take a shortcut. From here, your markers, right? For this particular instance, they are quite smart. You prove that 2 are the same already. Everybody knows the third one is going to be the same already. Okay? So from here, you write next. Since 3 pairs of corresponding angles are equal, triangle ABC is similar to triangle APQ. Okay? Did I make a mistake when I wrote 3 pairs? Did I make a mistake? I only proven 2 pairs, no? So did I make a mistake? No, I didn't make a mistake because I said this is the only instance that we can take a shortcut. Okay, we know that because two are the same, the third angle must also be the same because angles are a triangle. If you are uncomfortable, if you are kiasu, you can go and find the third angle over here. Put it inside there. Then you write down angles are a triangle. And prove that they are the same. Then you just spend maybe 1 minute more only compared to your friends, but you make sure you better not make a mistake. Okay, and so this is our answer. Questions? Yeah. Huh? AQP, ACB, why? Yes, corresponding angles again. Can. Yes. Okay. The very definition of similar triangles requires that the shapes be the same. Correct? How do we tell that two shapes are the same? We look at the corresponding angles. Here I have one pair of corresponding angles being equal, right, in red. Here I have a second pair of corresponding angles being equal. Since these two are equal, I confirm know that the third pair must also be equal. So this is what it means. Three pairs of corresponding angles are equal. That is how we result in the same shape, specifically similar shapes. Okay, next one. Oh, look at this. Side, side, side similarity. What do you think this test requires us to do? All three sides same. Okay, so you've been listening to the lesson. The ratios of the three corresponding sides must be the same, right? Then we can prove that they are similar. Now, do you see why we insist that you do not write AAA? Do you know why now? Because if you write AAA similarity test over here, what are you going to write for this? Are you going to write SSS test?
It could be congruent test.
Then I've already got SSS, right? That is why I don't want it. Oh, sorry, that is why we don't want it. You're not allowed to write side-to-side similarity test. Instead, you should be writing ratios of three pairs of corresponding sides are equal. This is the name of the test that we're going to use. Okay, this is what we're going to quote. So likewise, put a star, memorize. Okay, next, try 6. What else? How do you tell what are corresponding sides? If I don't give you the name of triangle, I tell you they are not drawn to scale. There is no hypotenuse. It's not right angle. You are referring to longer side, right? So the longer side must be corresponding to the longer side, right? Then what else? Shortest must be with the shortest. And the last one is whatever is left. Okay? So these are some things that we can tell. So now, I want to prove that they are similar. Two triangles drawn out already. I'm going to use ratio of corresponding sides. Choose either, you start with this. Okay, let's call this numerator. Then this one denominator. Okay? The reason I write this is because we are going to find the ratio of the corresponding sides now. Something has to be in the numerator, something has to be in the denominator. Whichever one you choose doesn't matter as long as you stick to it. Okay, so in this case, I chose the smaller one to be my numerator. So I write AC over, what should I write next? DF. Okay, equals to? Not 1/4, write 12 over 16 first. And this is, wait, why 1/4? This is 3 over 4. Okay, next, what do I write? AB over DE. So you see, I don't like to use ratio. I always change it to fraction. So 6 over 8, which is 3 over 4. And obviously the last one, AC over DF, also 12 over...
Is it BC over EF.
BC over EF is 9 over 12, which is 3 over 4. What do you see? These are proportion. What did they say? Ratio, right? Ratio of 3 pairs of corresponding sides. Okay, so these are ratios of 3 pairs of corresponding sides. And we see that, yeah, they are equal. We see that they are equal. So, once we have this working over here, we say that since 3 pairs of corresponding, since ratio of 3 pairs of corresponding sides are equal, then triangle. We follow exactly a question. What did it say? A, B, C, D, E, F. A, B, C similar to triangle D, E, F. That's for part A. Okay. Some people would have chosen to do it this way. Denominator, numerator. So they would have obtained DF over AC equals to 16 over 12, which is 4 over 3, and then so on. You get 4 over 3, 4 over 3. Same thing, same ratio. Okay? Now for the last part, find angle Y.
104.
Yeah, obviously angle Y is 104. So for part B, angle Y equals to 104. Okay. Equals to angle DEF, which is 104 degrees, corresponding angle of similar triangle. Okay, so that's the reason over there. We call it
Ratio of corresponding sides.
over here, highlight, put a star, memorize. Got it. Example 7. So we've got one pair of corresponding side, another pair of corresponding side, which we can find the ratio 5 over 3 and 5 over 3. So because this is 35 and I do not know what this is, I cannot use 3 pairs of corresponding sides. Therefore, I must use the included angle, which is given to be 86. So you see, over here, I've got an angle given. These two are found, so I state that they are similar because ratio of corresponding side included angle are equal. I do not say that it is the SAS similarity test. Do not say that. Okay? Then for part B, you can read it yourself. Find the value of x. Obviously, they are also proportional because they are similar. Okay? So your homework will be uploaded